Hi guys, welcome back to Distinction in Mathematics. This is the fourth video based on proving identities in trigonometry. Please watch all the videos without wasting any time. Let's get right to it. All the trigonometric functions cos, sine, and tan are positive on the first quadrant. Sine is positive on the first quadrant and also positive on the second quadrant where cos and tan are negative. Sine is positive on the first quadrant and also positive on the third quadrant where sine and cos are negative. Cos is positive on the first quadrant and also positive on the fourth quadrant where sine and tan are negative. Now these are very important trigonometric ratios that you have to know before you answer trigonometric questions. Also keep this in mind, this is not something you'll find at the back of your question paper, so you have to know it. 90 degrees minus x lies on the first quadrant where all the trigonometric functions are positive. So cos is also positive on this quadrant. But remember what I told you to keep in mind. At 90 degrees plus or minus, sine changes into cos and cos changes into sine. So since we have a positive cos at 90 degrees minus x, when cos changes into sine, it is also going to be positive. So we have a positive sine x. The strategy to work around this is to remove all the brackets first, so we are dropping cos y as it is. Sine multiplied by a negative angle gives us a negative sine, so we will have a negative sine y. And 180 degrees plus x lies on the third quadrant where cos is negative, so we're going to have a negative cos x. Three 60 degrees plus y lies on the first quadrant where cos is positive, so we're going to have a positive cos y. And 360 degrees minus x lies on the fourth quadrant where sine is negative, so we're going to have a negative sine x. Remember, the strategy is to remove all the brackets before we move any further. When you look at this, it looks like a compound angle formula for sine. So we're going to multiply these two together and position it in a way that it looks like sine cos, cos and sine. How exactly you differentiate the compound angle formula for sine is the signs. So because of this plus sign, we're going to have sine x plus y. The same applies here. We have a minus sign, so we're going to have cos x plus y. And we already know that sine over cos equals tan, which equals the right hand side. Thank you guys for watching. I'd like to see more people join the team, so please share this video. If you find this video helpful, please give it a like. I'd like to know where you find a challenge in proving identities or trigonometry as a whole, so please leave your questions in the comment section. And if you haven't subscribed, please click the subscribe button. We'll see you on the next video.